In this video, we're going to take a look at tutorial question 1 from page 42 of the course notes. So in this problem, the proposed jetty from an oil terminal has been constructed in timber, and we're given a cross section of this support, and we're given some details about the dimensions. It's a simple rectangular section, and also the bending moment that's going to be applied. So we've got a bit of information immediately, and it's worth noting this down when we get given this in a question. So I'll make a wee note of what we've been given here. We've been given B, that's 50 millimeters, that's the breadth of our beam, and we've been given D, that's 150, D equals to 150 millimeters. In fact, I'll just make that a little bit neater. And we should know already that before we go any further, we actually have the information we need to work out the second moment of area. But before we do that, we have another piece of information, so let's write it down as well. We've been given the bending moment that's going to be experienced by the beam here, and that is 600 Newton meters. Just a reminder that some of these are millimeters, some are meters, and we start to use these things together, that we're going to have to have all the same units. And let's have a reminder of what we're finding out here. So we've been asked to find out maximum bending stress. So that's given by this formula here that we've encountered in the course notes. So we've been given M, we have what we need to work out I, and Y, what's Y? Well, remember that Y is a distance from the neutral axis to the furthest away piece of material. So if we have a look here, that's just going to be half of D, because the furthest away bit is the top or the bottom of the beam, because in this case Y is the same either way, and it'll be half 150. So Y is going to be 75 millimeters. What the dimension Y tells us is how far away the furthest away piece of a section is from that neutral axis, which is the same as our centroid, that dotted line across the beam. So we need to find I. We don't know I yet, our second moment of area. So I is currently unknown, and our maximum stress is unknown, and this is what we're aiming to get to in this question. So let's start off with, I'll rub this out now, with our equation for second moment of area about the x-axis, or x-axis. If you look up your course notes, you'll see from the notes the formula for a rectangle is b times d cubed divided by 12. And we have these values, so we've got 50 times 150 cubed divided by 12. So that's a task for the calculator. I'll put that in. And what our calculator will give us out is this number here, 1406250, but we'll simplify that to 14.063 times 10 to the 6 millimeters to the 4. And again, I just chose to write that times 10 to the 6 because quite often a lot of our numbers with second moments of area are of this order. It would have been equally correct to have written 1.4063 times 10 to the 7. Or at this stage in the question, leave the number written out in full because it's not our final answer. But that gives us our value for I, so we can remove this question mark over here with the answer that we now have, which is 114.063 times 10 to the 6 millimeters to 4. Now, the last thing we need to do is convert our units for the bending moment into millimeters. The newtons is fine, we're happy with that. We want to have it in millimeters, so we'll multiply this We want it in millimeters, and we want rid of meters. So we've got 1,000 over 1. So this will be 600,000 Newton millimeters. And this is important because when we do our calculation for the bending stress, everything needs to be in millimeters and newtons. That's what we want, so that we get an answer in newtons per millimeter squared. So let's do that calculation. So remember, our equation for bending stress is equal to m times y over I. We now have all these numbers. M we've got in our correct form of 600,000 Newton millimeters. Y we worked out was 75. And I we've just calculated over here is 14.063 times 10 to the 6. So we put all of this into our calculator as well, and this will give us our final answer. This gives us an answer of 3.2, with a bit of rounding, 3.2 newtons per millimeter squared. So that's how we find our second motive area, convert our units, and use them to find the maximum bending stress in this question.